So recursion and Fibonacci numbers. We're going to use the Fibonacci numbers or Fibonacci sequence to explain recursion and how it works. So let's see what is Fibonacci sequence, the definition of Fibonacci sequence. The definition is that each number is the sum of the two preceding ones, starting from 0 and 1, and that is Fibonacci of 0 is 0, Fibonacci of 1 is 1. Otherwise, Fibonacci of n is Fibonacci of the number previous to it, preceding it, f of n minus 1, plus f of n minus 2. An example of that is 1, 1. So Fibonacci of 0 is 1, Fibonacci of 1 is 1, Fibonacci of 1 is 1 plus 0, 1, Fibonacci of 2, 1 plus 1 is 2, Fibonacci of 3, 2 plus 1, 3, Fib of 5, 3 plus 2, 5, and so on. So to translate this into code, let's say we're calculating the Fibonacci of 3. This means that we need to calculate Fibonacci of 2 plus Fibonacci of 1. So we can use the same function to call itself to calculate the previous number, just like this equation showed. Let's see what this looks like in code. You can activate the IPython virtual environment, and if you want to see how this activate shortcut or aliases work, you can look at it in a previous video for creating Python virtual environments or shortcuts for virtual environments. Okay, so let's create a function called fib for calculating Fibonacci, and say if n is less than 2, just like how the function says. So we have 0 and 1, so anything that's less than 2 returns the number itself. So f of 0 is 0, f of 1 is 1. Oops, return n. Otherwise, you can just return, the Fibonacci of the number, the preceding number, so n minus 1, plus fib of n minus 2. Okay, let's test that. Let's calculate fib of 3. 2, so 0, 1, 2, 3, 2. Fib of 4 is 3, 0, 1, 2, 3, 4, 3. Fib of 5 is 5, fib of 6, 8, and so on. So let's see how this works and what's happening in the background. So here we're going, so like for example, Fibonacci of 3, we're going through the first if, it's not less than 2. So we're returning the calculation, we're returning a function call. So the function is calling itself to find out what is the fib value of 3 minus 1, which is 2, and what is the fib value of 3 minus 2, which is 1. And to better explain this, let's draw the function calls. So here we have a function called fib, and it takes an argument, a number that will use that number to calculate Fibonacci. So let's put that here. So let's take an example that we just used for fib of 3. So to calculate fib of 3, 3 is it's not less than 2, so fib of 3 is 3 minus 1 plus 3 minus 2. So this is copy that. So fib of 2 and fib of 1. Now, to calculate fib of 2, we want to calculate fib of 1. And fib of 0. All right, so let's go back. To calculate 3, we want 2 and 1. To calculate 2, we want 1 and 0. So these two will return. This will, it's a weird color. This will return, okay, so let's call that 1. So this will return 0. This will return 1. This will return 1. This will, oops. This will return 1. This is not working well. Let's change that to text. That might be easier. Sorry about that. Textile 0. Okay. So this will return 0. This will return 1. This will return 1. This will return 1 plus 1, 2. So Fibonacci of 3 is the final number 2. So you can see how this can grow much bigger if we calculate bigger numbers. And to save time on drawing boxes, let's modify the code where it shows us how it's calculating, what is calculating at this moment of time. So let's add here a print statement to say we are returning n, and here we'll say we are calculating Fibonacci of n minus 1 plus fib of n minus 2. Okay, let's try that. So, okay, calculating Fibonacci of 3 is calculating fib of 2 and fib of 1. Fib of 2 plus 1, and then to calculate fib of 2, we want 1 and 0, so we're returning 1, 0, 1, and 1 plus 1 is 2. So let's look at 4. We see how every layer 3 plus, so we're calculating 3 and 2, then 2 and 1, 1 and 0, and then we're returning 1, fib of 0 is 0, and fib of 1 is 1, and calculating fib of 1 again, because we want fib of 1 here, and that is 1 and 0, so we're returning 1 and returning 0. So here we can see the repetition in a way that we're calculating Fibonacci of 0 and 1 multiple times, over and over. So Fibonacci 1 and Fibonacci 0, you can see that's being repeated. So if we go to a higher, like 8, you can see this can grow very big very quickly. So to calculate 8, we want 7 and 6. To get 6, we want 6 and 5. No, so we want 7 and 6. To calculate 7, we want 6 and 5. To calculate 6, we want 5 and 4. To calculate 5, we want 4 and 3. So you can see the repetition here. We're recalculating Fibonacci's over and over, and we're returning, we're calculating 1 and 0 once, 1, how many, let's see how many times. So we're calculating 1 and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, too many times. So that's why, even though recursion seems like it's very simple function to write, it might be not the most efficient way, because these calculations can grow very big very quickly, and as a matter of fact, if we go a big number like 100, this will just take forever. Just continues calculating Fibonacci's, and I don't know how long this will take. I mean, it might literally take forever. So I'm going to kill it. So yeah, there you go. That's recursion, and an example for using recursion is by calculating Fibonacci numbers. It's a very common example for recursion. We can see in future videos how we can use other algorithms or other techniques to calculate Fibonacci more efficiently and faster.